Hello students, welcome to Learner's Planet Theory Session 3 of Carbon and its Compounds. Now in our previous session we discussed about the allotropes of carbon and the properties of carbon. In this session we will be discussing about the organic compounds, their structures, about the hydrocarbons, the saturated hydrocarbons and the unsaturated hydrocarbons, as well as their structures. So let's start with our session. Now here children, what is an organic compound? You must be wondering actually what it is. So organic compounds, these are the compounds of carbon, right? Now the compounds of carbon are known as organic compounds. Say your urea, it is a compound of carbon. Protein is a compound of carbon. Carbohydrate, a compound of carbon. Likewise lipids, a compound of carbon. Your chlorophyll, hemoglobin, all of them contain what? Carbon. So these are called as organic compounds. The carbon compounds or organic compounds are covalent compounds having low melting and boiling points. As I previously told you that carbon cannot form ionic compounds. Okay, so it is forming what? It is forming a covalent compound. Now what do you mean by a covalent compound? That is a compound having a covalent bond. Say I am writing a monomer of protein. Now your protein consists of, there is a carbon at the center to which there are 4 bonds. Now these 4 bonds, to these 4 bonds different molecules are attached. Say there is COO minus, there is NH3 plus, there is one hydrogen, as well as this can be either an alkyl group, that is a carbon, or it can be a hydrogen. Now this is the monomer of organic compound. Now in this case children, so students, this is the monomer of protein. There are number of amino acids which link together to form a protein. Okay. Now in this case, say a carbon. Carbon is forming how many bonds here? 1, 2, 3 and 4. What are all these bonds? These are covalent bonds. Now when we were discussing the properties of ionic and covalent compounds, I told you that covalent compounds have a low melting point or low boiling points. Okay. Say we'll take another example of say any alcohol. Just take an alcohol like ethyl alcohol. We'll be discussing it later also. Now in this there is a covalent bond. For boiling an ethyl alcohol, so there are what children? Students, there are so many molecules of ethyl alcohol. And what type of force of attraction is there between them? Say there are number of molecules of ethyl alcohol in say 1 liter or 1 ml of ethyl alcohol. Now what is the type of force in between the two molecules? This is what? This is van der Waals forces of attraction. Now this van der Waals forces of attraction is a very weak force, right? So these molecules have got low boiling and melting points. Your melting and boiling point depends on the force or the type of force of attraction between molecules. Ionic compounds have got very high melting and boiling point because of the strong ionic bond as well as the electrostatic force of attraction between the molecules. So these covalent compounds have low melting and boiling points. most of the organic compounds are hydrocarbons. Hydro and carbons. So if we dissociate this word, what we will get? Hydro, hydrogen and carbon. Carbons containing only carbon and hydrogen or their derivatives. So your ethyl alcohol is a hydrocarbon. Okay. Now let's see the structures of hydrocarbons here, or the examples. This is what? This is the H4. Its name is methane. We will discuss the nomenclature later. C2H5OH. This is alcohol or ethyl alcohol. C2H2 is what? It is ethene or ethine. It is ethine. C3H7 is propyne. It is propyl. It is a radical. C3H7 is a propyl. Or I can write it as C3H8. It would be what? It would be propane. So students, don't take tension. We will be discussing nomenclatures separately. Here I just wanted to tell you the examples. C2H6, this is ethane. So these are some examples of hydrocarbon. You can see that these are made of carbon and hydrogen and oxygen only. So carbon and hydrogen is the sole constituent. Now these compounds are known as organic compounds because they were originally derived from living organisms. So originally they were obtained from the living organisms, so they are called as organic compounds. Now let's see what are saturated and unsaturated organic compounds. Saturated carbon compounds. A hydrocarbon in which carbon atoms are bonded by only single bonds is known as saturated hydrocarbon. The saturated hydrocarbons are also called alkanes. The general formula of alkanes is CnH2n plus 2, where N is the number of carbon atoms in one molecule of alkane. Say for example, there is C2H6. Now if I'll draw the structure of C2H6, what I'll get, there is one carbon here. This is bonded to the other carbon atom. How many carbons are there? There are 2 carbon atoms. Now how to put hydrogen with them? There are 6 hydrogen atoms. So what I can do is, I will put down I'll draw this structure vertically so that it is clear to you. Now in this case, this is C is single bonded to C, and it is further bonded to how many hydrogen, students? It is further bonded to 6 hydrogen atoms, and that too by what type of a bond? It is bonded by a covalent bond. So it is H, H, H. So this is the structural formula of ethane. Right? Now here what is happening? All are bonded by a single covalent bond. Now what is the general formula of alkanes? Cn H2n plus 2. What is N here? N is the number of carbon atoms. So in ethane, how many carbons are there? 1, 2. So what would be N? N would be 2. Okay? So I'll write here C as 2. Now H, how many H would be there? 2 multiplied by 2 plus 2. So how many H we are getting? 6. So it is C2H6. This is what? This is your ethane. Then we have got C3H8. That is what? That is propane. Again, there are how many carbon atoms? There are 3 carbon atoms. And by what type of bond they are bonded? They are bonded by a covalent bonds. So to this, how many hydrogen atoms are attached? To this, 8 hydrogen atoms are attached. How? To each carbon, to this carbon, that is which is the left hand side, there are 3. And I have told you that carbon is what? Tetravalent. That is how many bonds carbon can form? It can form 4 bonds only. So depending on that, you have to place the hydrogen atoms. Carbon should not be trivalent. It should not be pentavalent. It should be tetravalent. So this is your structure of propane. So likewise students, you can draw the structure of alkanes just by putting single bonds in between every atom. And remember, carbon should always be tetravalent. Now this is the electron dot structure of ethane. See this carbon. This is how many electrons the crosses? 1, 2, 3 and 4 in the valence shell. The second carbon has also got 1, 2, 3 and 4 electrons. Now the electrons between 2 carbon atoms is, one is shared by first carbon and the other one is shared by second carbon. And they are sharing electrons with 4 other hydrogen atoms. 6 other hydrogen atoms. Now, is the octet of carbon complete? Let's count the number of electrons with the first carbon. 1, 2, 3, 4, 5, 6, 7, 8. So the octet of first carbon is complete. Now let's see the octet of second carbon. Is it complete? Yeah, it is also complete. So carbon is completing its octet or attaining a noble gas configuration by covalent bonds. Now, let's see what are unsaturated hydrocarbons. A hydrocarbon in which 2 carbon atoms are bonded by a double bond or a triple bond is called unsaturated hydrocarbon. That is your alkenes. There is C double bond C. And its general formula is CnH2n. Alkynes. Alkynes is what, students? It is carbon triple bonded carbon. That is C. There is 3 bonds between 2 carbon atoms and the general formula is CnH2n minus 2. Now let's take up the example. Say alkene. There is, what is the general formula? If I'll write here alkene. So what is the general formula, students? It is CnH2n. Now, if n is equal to 2, so what will be the formula of the compound? It would be C2H2n multiplied by 2. So what I will be getting here is C2H2. So let's draw its structure, how it would be. There are only 2 carbon atoms. So C, and I'll put a bond in between 2 carbon atoms. So this is another C. Now to how many hydrogen atoms it is bonded? It is bonded to only 4 hydrogen atoms. That is, each carbon is bonded to 2 hydrogen atoms. Now let's put the hydrogens here. This is 1. This is 2, This is 3 and this is 4. So, now is the tetravalency of carbon complete? There is still one electron left with both of them. There is this one electron is left with both of them. So here your carbon is trivalent. 1, 2 and 3 bonds. Right? So how many bonds are there? 1 bond, 2 bond and 3 bonds. So each carbon is having 3 bonds. And carbon is tetravalent. So what is done is that these two electrons, they are shared and they form what? They form a double bond. Okay? So a double bond is formed between two carbon atoms by the electrons which are not paired. Likewise, you can write the formula of any alkene using the value of N. Now your alkynes, what is the general formula? CnH2n minus 2. Say if alkyne, I have C2, so it would be what? H2. How can I draw the structure? See, there would be a single bond I'll draw first, and these carbons are bonded to single hydrogen atoms. Now how many electrons are left with carbon? 2 electrons. So what is done is that they are shared and then they form what? C triple bond C, H and H. So this is how your alkynes are formed. So by using the general formula, you can form large number of or the number of different alkenes and alkynes. So this is the structure of ethene. How many electrons are shared here? 2 electrons by the first carbon and the 2 electrons, these 2 electrons, say this 1 electron is by this carbon. This 1 electron is by the second carbon. This is again 1 by this carbon and 1 by the second carbon. So it is forming a double bond. This is ethene. Similarly, there is ethine. So this electron by first carbon, this 1 electron by second carbon, this again by first carbon, this again by second carbon, first carbon, and this is again by second carbon. So likewise your triple bond is formed. Now likewise your carbon, it forms chains and branches and also the sheets. Like carbon atoms form chains of varied lengths and rings due to its catenation property. So I've told you students, what is the catenation property? It is the self-linking property of an element. Is what? Catenation property. So that is why your carbon is forming long chains like this, C, C, C. And now you must be understanding where I have not written anything, it means there is hydrogen. This chain is CH3, CH2, CH2, CH2 and CH2. Okay? So this is the long chain this carbon atom is forming. Why? Because of its property of catenation. That is the self-linking property. Why it has the catenation property? Because of its small size. The covalent bond between carbon atoms are stable. Now the chains of carbon atoms may be linear or branched or cyclic or sheets and also the three-dimensional lattices. Now let's see the different types of chains this carbon atom is forming. This is what? This is a linear chain. So what I can put in front of bonds? Hydrogen. Hydrogen here. These are all what? Hydrogen. How can I write this? This can be written as CH3, CH3, CH2, CH2, CH2 and CH3. So this is your linear chain. Now in your books, students, you can also get the chain like this. I'll draw a different type of a chain which you'll get in your books. You must have seen chains like this. I don't know whether you have seen it or not, but in the organic books you can see the chains like this. Now what does this chain indicate, students? This is that at the corners where there are no atoms, it is CH3. And at the vertices, there are CH2. So what is this your chain? How many carbon atoms are there? Let's count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So how many carbon atoms are there in this? 9 carbon atoms are there. And your chain would be, if I write it in the form of a chain, not the zigzag, it would be CH3, CH2, bond in between, CH2, 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 CH2. How many are there? 1, 2, 3, 4, 5, 6, 7 and CH3. So what is this, children? It is an alkane or alkyne or alkene. It is alkane, students, because there are single bonds between the carbon atoms. So this is your alkane. So what is its formula? If I write its formula, it is CN. It is an alkane. It is visible that there are only single bonds. So what is the formula of an alkane? Alkane's formula is CnH2n plus 2. How many carbons we have counted? We have counted 9 carbon atoms. So it should be C9. And H, what it should be? 2n, that is 18 plus 2, 20. So this is your carbon chain. So carbon forms linear chains like this. Now let's see how branching is there in the chain. This is your branch chain. So wherever, students, you are finding that there is no atom, there is a hydrogen. So this is your branched chain. Again, there are what, students? There is a single bond between carbon atoms. So as there is a single bond, it is again an alkane. So what would be the formula of this? Let's count the number of carbon atoms. 1, 2, 3, 4, 5. So how many carbon atoms are there? What is the general formula of alkanes? It is CnH2n plus 2. So how many carbon atoms are there? 5. So what will be the number of hydrogen atoms? It would be 12. Okay. Now this is a branch chain. It would have been written in a linear chain form also. Okay. So carbon also forms branch chain. Now one reason behind this is the unique property of catenation of carbon atoms. So this can come in your reasoning type of question, that why carbon is forming a branch chain or a linear chain or rings or sheets. So the answer to all these questions is what? That carbon has unique property of catenation. Now here, carbon is also forming cyclic rings. That is, one of the ring is cyclopropane or cyclobutane. I'll tell you the nomenclature in later sessions. Here, this is forming a ring. Now, is this valency of carbon satisfied? This carbon is bonded to two bonds, one bond this and one bond this one. And again it is bonded to two hydrogen atoms. So carbon is tetravalent. It is bonded to 4 bonds. It has 4 bonds. So this can be written as in a cyclic form also. What would be the formula of the students? It would be, how many carbons are there? 3 carbon atoms. How many hydrogens are there? 6 hydrogen atoms. So C3H6 can be written in the cyclic form, or it can also be written like C and C. How many hydrogens are there? There are 6 hydrogens. So what can I do? I can put hydrogens. Let's put 1 hydrogen here. Now this is again 3. This is again bonded to this. Are the other hydrogens complete? No, 1 more is left. So what I can do is I can put this hydrogen in the first carbon. Now, are the valency of carbon satisfied? This has got 4. This has got 1, 2 and 3 only. This has also got 1, 2 and 3 only. So how can this be satisfied? This be satisfied by putting a double bond in between. So this is what? This is an alkene. Now your C3H6 can be written in a cyclic form also, forming cyclopropane, and it can be also written in the form of an alkene, that is a propene. We'll discuss the nomenclature in our next sessions. So this is propene. Likewise, let's see on next structure. How many carbons are there? There are 4 carbons. So it is C4. How many hydrogens are there? Count it quickly. It is 8 hydrogen. So how can we write it? We can again make a chain. Okay. Now what I'm doing is I'll put on hydrogens so that I can know where I have to put the double bonds. So what we can do is we can put the double bond to any of the carbon atoms. The only thing you have to keep in mind is that carbon should be tetravalent. In any of your structures, carbon should not be pentavalent or trivalent. So what is this? This is an alkene. So its name would be butene. So these are cyclic compounds. Again, carbon is forming a cyclic compound due to its property of catenation. Likewise, this is cyclohexane, that is cyclic again. This is cyclobutane again here. So what I can write here is, it is C6H. How many H are there? 12. Because this has the formula similar to alkenes. And this is what? Cyclobutane, that is C4H8. So this carbon also forms lots of aromatic compounds which have got double bonds or alternate double bonds in them. So for this session, students, I'll conclude, and in the next session we will be discussing about the nomenclature of hydrocarbons, the IUPAC, as well as the trivial names of hydrocarbons. So thank you, students, for listening patiently. We'll be meeting in the next session of IUPAC nomenclature.